So I wanted you guys to see another example. So I actually am going to do problem 12 from your homework. So problem 12 from your homework was 2x squared minus 4x divided by x squared plus 4x plus 4. So the very first thing we need to do is we need to factor this. So the top is pretty easy to factor because it's just a GCF. So I have 2x squared minus 4x. Well, I can factor out a 2x. And if I factor the 2x out, I'm left with x minus 2. And then in the denominator, x squared plus 4x plus 4. Well, I need two numbers that when I multiply them, they give me 4. And when I'll add them, they also give me 4, and that's going to be plus 2 and plus 2. So my factored form is 2x times x minus 2 divided by x plus 2 times x plus 2. So vertical asymptotes, if you'll recall, is whenever our denominator is equal to 0. Well, since the factors of my denominator are the same, I do not have to solve both of them. So I have x plus 2. I need to set it equal to 0. So I'm going to minus 2 from both sides. And I get that there's a vertical asymptote at negative 2. The next thing is my horizontal asymptote. Well, that's my triplets, Bobo, Botan, and Betsy. So if I look at the degree, there's a 2 here and a 2 here. That's my exponent of both. So that means the bottom is equal to the top, so it's Betsy. So that means that we're going to divide our coefficients. We're going to divide 2 by the coefficient of x squared, which in this case is just 1. So I get y equals 2 divided by 1, which is 2. So I have a horizontal asymptote at y equals 2. So my x-intercepts happen whenever the numerator is equal to 0. So if my numerator equals 0, then that's two factors there. I have 2x equal to 0, and there was x minus 2, which I'm going to set equal to 0. So that means I have an x-intercept at 0, and I have an x-intercept at 2. And the next thing I look at is if I have a slant asymptote. Well, remember, a slant asymptote only happens when you have Botan. And that means that you have the bigger degree on top. Well, notice up here we had Betsy, not Botan, so that means that there is no slant asymptote. And the last thing I check for is holes, and holes occur whenever there is a factor that's in common. If there's a factor in both the top and in bottom that's the same. And I did not have any factors that were the same on both the top and the bottom. Because on top, my factors were 2x and x minus 2, and on bottom it was x plus 2, and those are not the same. So that means that I have no holes in my graph. So there are none here as well. So then I can move over to my interval line. On my interval line, I label that with a couple things. I label that with my vertical asymptotes, and I label that with my x-intercepts. So I had a vertical asymptote of negative 2, so that's the first thing that's going to go on my number line because I am putting these in order. And then I had a x-intercept at 0, and I also had another x-intercept at positive 2. So I've gone ahead and labeled my table in here. So remember that my intervals over here on the left side come from my number line. So my first one was from negative infinity to 2, then from negative 2 to 0. The next one is from 0 to 2, and then last one from 2 to infinity. So that's where all these came from. And I went ahead and put my factors in the top. Remember, I have to list each factor. So I have 2x and x minus 2 from the top, and then x plus 2, x plus 2 from the bottom. So I've got to pick a number in each of these intervals and figure out what happens to each of the factors in that interval. So if I pick a number between negative infinity and negative 2, let's say negative 5, well, from 2 times negative 5 is going to give us negative 10, so this interval is negative. Negative 5 minus 2 is negative 7, so this interval is negative. Negative 5 plus 2 is negative 3, so this is negative, which means this x plus 2 is also negative. So if I have negative, 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 then that's going to give me a positive function on the interval from negative infinity to negative 2. That means that from negative infinity to negative 2, my graph is above the x-axis. And remember that to get this in sign here, I'm just using my sign rules of multiplication and division. So, and it's the same for either one. A negative and a negative is a positive, then a positive and a negative is a negative, and a negative and a negative is a positive again. So I'm just using those sign rules of multiplication and division to figure that out. So next thing I'm going to do is pick a number that's between -2 and 0. So I'm going to pick 1. So 2 times 1, sorry, -1. So 2 times -1 is negative. -1 minus 2 is -3. -1 plus 2 is +1. -1 plus 2 is +1. So if I have a negative and a negative and then a positive, well, this negative is really going to become positive. Then I have positive, positive, positive. So that sign of that function is positive. So from -2 to 0, it is also positive. Then I need to pick a number between 0 and 2. So I'm going to pick +1. Well, 2 times +1 is positive. 1 minus 2 is negative. 1 plus 2 is positive, and so 1 plus 2 is positive again. So if I have positive, negative, positive, positive, that's going to be a negative function on that interval. And then I pick a number from 2 to infinity, so let's pick 3. And 3 times 2 is positive. 3 minus 2 is positive. 3 plus 2 is positive, and 3 plus 2 is positive. So positive, 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 positive is going to give me something that is positive. So I'm going to go back up here. So that tells me that between 0 and 2, my graph is going to drop below the x-axis. When it gets back to 2, it's going to be above the x-axis. Remember, there's a vertical asymptote here at -2, and it's positive on both sides, so that means both sides are going to be coming from positive infinity. So now I'm ready to graph. So the first thing I'm going to do is I'm going to graph all my asymptotes and my x-intercepts, and if I had holes, I would graph those as well. So I had a vertical asymptote at -2. So I'm going to go ahead and draw that in. So it's just going to be a vertical line. The slope is undefined, by the way. Then I have a horizontal asymptote at +2. So it's going to cross the y-axis at 2. I also know that my graph has an x-intercept at 0, and it has an x-intercept at +2. So to figure out what my graph's going to look like, I have to go up here back to my table and to this interval line that we drew to help us figure it out. So from -infinity to 2, so from all the way out here at -infinity until it gets to 2, that graph is positive. That means it's above the x-axis. So I've got a couple options. It could be in this section of the graph up here, or it could be in this section of the graph down here. Those are my two choices, because that's the only two sections of my graph. Well, in the top section, my graph is positive because it's above the x-axis. In my bottom part, it's positive here, but it's negative down here. So if this graph is supposed to be positive on this interval, which it is, because notice it says from -infinity to -2 it's positive, that means that it has to be in this top part, in this pink part here. So when I graph my function, it's going to be like this. And you are always welcome to use your Desmos or to use a graphing calculator to help you decide what the function should look like in that interval. So then we know that from -2 to 0, it's positive, so it's going to be above the x-axis here. And then from 0 to 2, it's negative, so it's going to drop back below the x-axis. And then from 2 to infinity, it's positive, so it's going to be positive again. And again, you are welcome to use Desmos or a calculator to graph this for you so you can actually see what it looks like, because finding these graphs is the most difficult part. What I'm concerned about is I am concerned when I look at this, I want to make sure you know how to find the vertical and horizontal asymptotes, that you know how to find a slant asymptote if there is any, that you can label your intercepts and you can label your holes if there are any. So you're welcome to use your graphing calculator to help you graph this function, which I've already done that, and know that my graph comes down from positive infinity, drops below the x-axis, comes back up, and goes out towards 2. So it approaches 2. So this is what my function looks like. So my domain, well, the domain is easy to figure out because the domain is affected by the horizontal asymptotes in the holes. The vertical asymptotes in the holes. So my domain is going to be from negative infinity is less than x, which is less than negative 2. Or negative 2 is less than x, which is less than infinity. To find my range, this is a little bit more difficult because, as you can tell, the graph doesn't go all the way down here to negative infinity. It has a minimum value here. So I'm going to use Desmos to help me with this. So you can see that I have copied my Desmos graph on here. I just took a screenshot of it from my iPad. And this is roughly what it looks like. So it matches pretty well with what we had already drawn. And it's found the minimum value for me. So it tells me the minimum value is negative 0.25. So that means that my range is y's that are greater than or equal to negative 0.25. Or you could write that it goes from negative 0.25, which is less than y, which is less than infinity. So both times I wrote mine in inequality notation, but like I told you guys, I don't care if you write it in inequality, set, or interval. You just need to be comfortable with all three of the notations. I'm going to help you start problem 11, but first you need to know that on problem 11 there was a typo, and standard form should have been y equals, or f of x equals, x squared plus 2x minus 8 divided by x minus 1. So that's what standard form should have been, which allows us to factor. So if I want to factor x squared plus 2x minus 8, then I know I need x, and I need two numbers that when I multiply them, they give me negative 8, which tells me one of my numbers should be positive, one should be negative. And when I add those same two numbers, it gives me a positive 2. So my factors end up being x plus 4 and x minus 2, and that's divided by x minus 1. So if I want to find my vertical asymptotes, remember your vertical asymptotes happen when the denominator is equal to 0. So whatever factors in the denominator equals 0. Well, that's x minus 1 equals 0. So I have a vertical asymptote at positive 1. Horizontal asymptotes, that's one of my triplets, Bobo, Botan, or Betsy. And if I look at my degree, it's 2 on top, and there's a degree of 1 on bottom. So that tells me that the bigger is on top, and that is Botan. So since it's Botan, there is no horizontal asymptote, but that tells me that there is a slant asymptote. So the way that I'm going to find the slant asymptote is I'm going to have to do long division. So I have x minus 1 outside, x squared plus 2x minus 8 on the inside. So I have to figure out what number times x is going to give me x squared, and that is going to be x. So then I multiply x times x is x squared, x times negative 1, so again I'm multiplying this on top by this factor outside. X times negative 1 is negative x. Since this is a division problem, I do need to switch my signs. So that'll become minus, that'll become plus. So then my x squareds cancel out. 2x plus x is going to be 3x, and then I bring down my minus 8. And I next need to figure out what times x is going to give me 3x. Well, that would be plus 3. And and 3 times x is going to be 3x, and 3 times negative 1 is negative 3. Again, I need to switch my signs, so it will become a negative and a positive there. So those 3x's cancel, and negative 8 plus 3 is negative 5. And if you'll recall, for my slant asymptotes, I ignore my remainder. So this piece right here is pretty much useless to me, and all I focus on is whatever I got on top. So my slant asymptote is going to be y equals x plus 3. So the next part is my x-intercepts. My x-intercepts happen when the numerator equals 0. So whenever the factors in the numerator equal 0, remember my factors in the numerator were x plus 4 and x minus 2. So I'm going to set each of those equal to 0. That means that I have an x-intercept at negative 4, and I have an x-intercept at positive 2. My holes occur whenever I have the same thing on top and bottom. I did not have any of that, so there are no holes in this one. That's when I have the same factor on top and bottom. So when I go to put things on my interval, I'm going to put all of my vertical asymptotes and my x-intercepts. So in numerical order, I first had an x-intercept at -4. The next thing that I had was a horizontal asymptote at 1. I'm sorry, vertical asymptote at 1. And then I had an x-intercept at +2. So these things will help me decide my intervals that I'm going to use in my interval table. And then that will help me, I'll put my factors up here and then figure out if my intervals are positive or negative on those, or my factors are positive or negative on that interval. So remember that the way we figured this part out, I'm not going to put any numbers in, I'm just going to fill in signs, so I want to make sure you understand this. So if I have negative, 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 what that means, remember 2 negatives gives me a positive, and another 2 negatives gives me a positive. So that means that a positive and a positive, this function is positive. The only time that it's going to be negative is if I have like 1 negative. So if I had 1 negative, then that would be negative. Or if I had 3 negatives, it would be negative, because an odd number of negatives, those 2 negatives don't cancel each other out. So if I have 2 positives and 2 negatives, that's positive. Obviously, if I have all positives, it's positive. And I'm just using my sign rules of multiplication and division, because when I'm multiplying, if I multiply a negative times a negative, I'm going to get something that is positive. And then if I multiply again a negative and a negative, I'm going to get something that is positive. So really I'm multiplying a positive and a positive, which is a positive.